if we're going to multiply binomials, we have to distribute these values. So here we have root 2k times root 2k. Then we have root 2 times negative 5k. Now this negative 5k does not have a root symbol, so that negative 5k is in front, and then root 2k. Then we have a positive 5k times positive root 2k, so that's positive 5k root 2k. And then we have the 5 times negative 5 is negative 25, and the k and k becomes k squared. Notice these are opposite terms, the same thing, so those will cancel out. Anytime you multiply a root by itself, the value underneath the root comes out, and then minus 25k squared. Okay, this is really 4x minus root 2x times the quantity 4x minus root 2x. So we're going to need to distribute. So I'm going to go ahead and take this 4x times 4x. 4 times 4 is 16. X times x is x squared. And then we have here 4x times root 2x is going to be plus 4x root 2x, but notice I have this minus here, so that should really be negative. Let's see if I can fix that really quick. Alright, so this should be negative here because I have a positive times a negative. And then we have a negative times a positive, so that's negative, and then 4x root 2x again, so that's this. And then I have a negative times a negative, so that's positive, and root 2x times a root 2x is just going to be 2x. So anytime you multiply the same square, all right, the same square root, that root symbol, the radical sign is going to go away. So now we just need to combine like terms. There's no x squared term, there's no x term, but I do have two root 2x terms. So I'm adding these together. Now x is also a variable, so these are really x root 2x terms. So the only thing I can really add is the negative 4. So this becomes 16x squared. Negative 4 plus negative 4 is negative 8. And then the term that's not changing is the x root 2x. Okay, this doesn't change when you add. Anytime you're adding like terms, you're really just adding the coefficients. And then we have plus 2x. And now we have no like terms. So that's our final answer. All right, for number 2, we have this triangle, and we want to first find the area of the triangle. So we know the area of a triangle equals 1/2 the base times the height. So we look over here. Here's my right triangle. This is the base, and this is the height. So base and height. So then we get 1/2 times root 2x squared times root 18x cubed. Anytime you have square roots, we can combine those underneath one root. So this becomes 1/2 the square root. 2 times 18 is 36. X squared times x cubed is when we add the exponents. So this is x to the 5th. The square root of 36 is 6. So that's a perfect square, 6 times 6. Now x to the 5th is x to the 4th times x to the 1st. So I can take the square root of x to the 4th. 4 divided by 2 is 2. That becomes x squared. And then I have an x left over. So then my final answer here for the area is 3x squared root x. Tangent of C is the opposite side over the adjacent, so SOHCAHTOA. So let's take a look at C. Okay, so if I look at angle C here, the opposite side is root 18x cubed. The adjacent side to C, this is a hypotenuse, so this is the adjacent side to C. So what we're going to have is the square root of 18x cubed over the square root of 2x squared. I can simplify that and put it all underneath one root. 18 divided by 2 is 9. X cubed divided by x squared. I have 3 x's on top, 2 on bottom, so I have 1 left over on top. The square root of 9 is 3, and I can't do anything with that root x. All right, AC over BC, let's take a look. AC is this hypotenuse side here, so that's going to be the square root of 5x to the 5th. And BC is this bottom length, so that is going to be divided by root 2x squared. We can combine this all under one root. This is 5 over 2. And then I have 5 x's on top and 2 x's on bottom, so that's x to the 3rd on top. But then we need to rationalize, so I'm going to rewrite this as 5x cubed over root 2. And I'm going to multiply the top and the bottom by the square root of 2. The reason why we want to multiply by the square root of 2 is to get rid of that radical. If I have a square root, I need perfect square, so I need 2 of these. So that leaves a 2 on the bottom. And then a square root of 10x cubed on top. X cubed is the same thing as x squared times x to the 1st. So when I take the perfect square, or when I take the square root of x squared, then I'm going to get an x on the outside. I have 10x left over on the inside and a 2. Okay, so the square root of x squared is this x. Then I have this x left over that stays on the inside because I can't take the square root of that. The 10 has to stay, and then the 2 was rationalized. All right, so we're given this function, and again, if I have this x here, okay, whatever this x is, I'm plugging it into this. So if I were to rewrite this, it's the same thing as saying f parentheses, so that was f of x equals root 5 times parentheses. So whatever's in the parentheses has to go in here because that's what that x value is. That's what this notation means. So when I come over here, I'm trying to evaluate this. So for all of these, it's the square root of 5 times what is ever, if I'm trying to evaluate f of x, whatever is this x goes in the parentheses. Well, here I'm replacing x with 5y to the 7th. So this is 25. Now y to the 7th is the same thing as y to the 6th times 1, or y to the 1st. Remember, we're rewriting this because if I take the square root, that means I'm really needing to divide the exponent by 2, and the biggest number in 7 that's divisible by 2 is 6. So 6 plus 1 is 7. Square root of 25 is 5. Square root of y to the 6th is taking the exponent 6 divided by 2. Okay, so then I have a y left over. All right, same thing. We're going to take the square root of 5 times 18a squared b to the 4th. 18 is 9 times 2, so this is a square root of 5 times 9 times 2 times a squared times b to the 4th. All right, We can't take the square root of 5. Square root of 9 is 3. We can't take the square root of 2. A squared, 2 divided by 2 is 1, so I have a to the first. B to the fourth, 4 divided by 2 is 2, so that's b squared. So I took the square root of all those. What's left over is 5 times 2, which is 10. And for C, we have the square root of 5 times 10 p to the negative fourth. So this is the square root of 5 times 10 is 50. So I evaluated this. 5 times 10 is 50. P to the negative fourth is p to the positive fourth on the bottom. So this equals the square root of 25 times 2 over the square root of p to the fourth. On top, the square root of 25 is 5. I can't do anything with root 2. The square root of p to the fourth is p squared because 4 divided by 2 is 2. All right, the side length of a square is represented by root 5x to the fourth y cubed. Determine an expression for the area of the square. So for a square, okay, remember a square has all the same sides. So if you have one side, a square, it is base times height or length times width, or it's also just side squared. Okay, now that's helpful because if it's side squared, and if this is the side of the square, then the area equals the square root of 5x to the fourth y cubed. But anytime you square a square root, that is the same as just the expression underneath the radical sign. Now for number 5, they give you the area of the square and they want us to find the perimeter. Okay, so we know the area of a square is s squared. And the perimeter of a square, so coming up to look at this, we're going to add up all the sides, s plus s plus s plus s. The perimeter is 4s. So if we can find the side, then we can multiply it by 4. So for the area, if it's 108x to the fifth y squared, if I'm going to solve for the side, I need to take the square root of this. Okay, and then once we get that, then we want to start simplifying. So 108, what can that be divisible by? 108 divided by 36. 36 times 3. So this equals 36 times 3 times, I'm going to rewrite x to the fifth is x to the fourth times x times y squared. I'm going to take the square root of that. All right, the square root of 36 is 6. 3 I can't change. The square root of x to the fourth is x squared. X can't change. The square root of y squared is y. And then I have 3x left over. Now this is the side. But we're trying to find the perimeter, so we're going to go back and multiply this by 4. So we have for the perimeter, 4s is going to be 4 times 6x squared y root 3x, and 4 times 6 is just 24.